Okay, everyone. Now we will see the next question here. As you can see that we are having a mass of 5 kg and that 5 kg mass drops by a distance of 2 meter. Okay, so this is the mass over here, and that particular mass is falling by a distance of 2 meter, and that is falling over this spring that is having a stiffness of 10 Newton per mm. So we need to calculate here what would be the speed of the block when that spring is deformed by 100 mm. So we need to calculate that value, and all the necessary data have been given. So we can consider the two position 1 as well as position 2 at x at that particular position of x1. So the value of velocity is 0 as well as deformation will be 0. Okay, but when it falls over this particular spring, it will compress it by 0.1 meter, such that we need to now find the velocity v2 when that is being compressed by this x2 equals to 0.1 meter, such that the value of k given here is 10,000 Newton per meter. So we will be using again here the work energy principle, and we can find out what would be the velocity v2 when that particular ball falls over this spring system. Okay, so now we will use that particular equation. Okay, so we can use that work energy theorem principle and can say that this work done would be equals to the change in kinetic energy of the body, that is change in the kinetic energy, and that work done would be equals to your half times of k times of change in the deformation. Initially it was 0, so 0 minus of 0.1 square plus, now that object is having a mass of 5 kg, and convert that into weight, multiply by the distance that it has traveled, that is 2.1, and then equate it by changing the kinetic energy of the body, that is final minus initial. Final is half of mv square, that is 5 times of v2 square minus of 0, and in this equation the only unknown quantity here is v2. Okay, so we can solve this equation and get this value of v2, and that will give equals to v2 equals to 4.6 meter per second. So that's the velocity of the particle, the ball, when such that at that particular stage that ball has compressed the spring to a depth of 10 centimeters. So at that particular stage, the velocity is v2 equals to 4.6. Similarly, if we can also have a condition where the velocity could be equals to 0. So at that particular state, it is going to give a maximum compression in this spring. So we can again work on work energy principle and can get this value of maximum compression in the spring at that particular case. Okay, so this is this numerical, and in the next numerical we will solve different problems on work energy. Okay, thank you.